Welcome to a journey beyond the frontiers of human knowledge. Today we will explore the wonders of the TRAPPIST system through the eyes of the James Webb Space Telescope. While the primary focus of the James Webb is to explore the origins of the universe, the telescope also serves to study the atmospheres of exoplanets in search of biosignatures. When we talk about biosignatures, we are referring to indicators of life on these distant planets. But before I tell you what signals the powerful James Webb has presented to the scientific community, let me explain to you what the capabilities of this ultra-technological telescope are. The James Webb Space Telescope is the most advanced window of humanity to the universe. Successor to the Hubble, the James Webb was designed to view the cosmos as never before, from the earliest planets and galaxies formed after the Big Bang to the atmosphere of distant exoplanets. Equipped with a primary mirror of 6.5 meters in diameter and an innovative solar shield the size of a tennis court, the James Webb can capture infrared light revealing secrets of the universe that were previously invisible. The main objectives and missions of the James Webb are ambitious: to unravel the mysteries of the earliest galaxies, study the formation of stars and planets, and investigate the possibility of life on other worlds. These discoveries and future revelations from the international scientific community, which go beyond the United States and analyze the data provided by the James Webb, promise to rewrite the astronomy books of Earthlings. Biosignatures could be identified if the telescope manages to detect signs of life and civilization, such as the presence of oxygen, methane, nitrogen dioxide, or even CF6 gases. For example, a recent comparative study on planet Earth as an exoplanet published in August 2023, but not yet reviewed by independent scientists, suggests that the James Webb can identify all relevant indicators of non-intelligent and intelligent life in Earth's atmosphere. Researchers have found that the quality of the simulation was up to the standards of the James Webb if observed by the TRAPPIST-1 system about 40 light-years away from our solar system. According to the study, the James Webb could detect life on exoplanets within this distance. Furthermore, researchers believe that the telescope could detect signs of extraterrestrial life up to 50 light-years away. So far, humanity has discovered only 20 exoplanets within a 50 light-year radius. However, estimates suggest that nearly 4,000 exoplanets may exist within the reach of the James Webb in this area, according to the Eden Project. According to the official website of the project, the first accurate maps of the world captured the distributions of continents and oceans, allowing travel and trade between continents. 500 years later, we have accurate and detailed maps of most planets in the solar system, a very good understanding of the Milky Way and the local group of galaxies, and even the large-scale structure of the universe. However, extrasolar planets continue to be difficult to detect. Many planets have been found so far, but almost all around distant stars, making detection and exploration of these planets difficult. It is important to note that the vast majority of planets, even around the nearest stars, remain unexplored. In this sense, the Eden Project works to discover and characterize habitable planets in the immediate solar neighborhood within a 50 light-year radius, which represents a small volume of the Milky Way but contains planets that we are likely to be able to characterize in the future, and also the planets that humanity may visit if interstellar travel someday becomes a reality. Despite facing numerous technical challenges and delays, the launch of the James Webb marks the beginning of a new era in space exploration. TRAPPIST-1, a red dwarf star. A year ago, in March 2023, TRAPPIST-1 once again became the center of discussions following a discovery by the James Webb Space Telescope. At that time, scientists revealed that a planet in the neighboring system lacks an atmosphere, hence the chances of life there are minimal. However, there are indications of life on the planet identified as TRAPPIST-1e, which shares similar size, mass, and radius to Earth, along with a balanced temperature close to that of our planet. TRAPPIST-1 is the name of a red dwarf star and also the solar system housing 7 planets, located 39 light-years away from Earth in the Aquarius constellation. The star is approximately 500 million years old. This planetary system began to be observed in the late 1990s, but it wasn't until 2015, through the TRAPPIST telescope, that scientists discovered 3 planets orbiting the red dwarf. Subsequently, 5 more bodies were found around the star, though the existence of one of the planets was initially dismissed, totaling 7 objects in the TRAPPIST-1 system. Despite being relatively close to Earth, TRAPPIST-1 is not visible to the naked eye due to its dim brightness. The planets were named TRAPPIST-1b through TRAPPIST-1h, with TRAPPIST-1g being the largest among them. This planetary system can also be recognized by the name 2 mass with a numerical sequence. One of the objectives of the James Webb Telescope is the analysis of exoplanets, planets outside our solar system, and TRAPPIST-1 is a beacon of hope for scientists. 3 of these worlds are located in the habitable zone of the star, prompting scientists' interest in them and the search for extraterrestrial life. However, TRAPPIST-1b and TRAPPIST-1c orbit in a region too hot to support liquid water, and recent observations also indicated it is unlikely they have an atmosphere. These exoplanets, B and C of the TRAPPIST-1 system, also receive a lot of radiation from the red dwarf. These recent findings, published in the astrophysical journal Letters, were consistent with previous analyses conducted by another instrument on the James Webb Telescope. However, according to recent research, TRAPPIST-1e has emerged as a potential candidate for a life-supporting planet. On NASA's website, one can find information about TRAPPIST-1e, which is an Earth-like exoplanet orbiting a Type M star and takes approximately 6 days to complete one orbit around its star. Its discovery was announced in 2017. Therefore, TRAPPIST-1e is one of the worlds orbiting an ultracool dwarf star and is also within the habitable zone of the star. What makes TRAPPIST-1 so special? Well, this system stands out because it doesn't just have 1 or 2, but 7 planets. Yes, you heard it right, 7, all orbiting very close to their parent star. This leads us to question whether any of these worlds could harbor life. Among these planets, TRAPPIST-1e stands out as particularly intriguing. Recent studies suggest that it is located in the habitable zone of its star, where conditions might be suitable for the presence of liquid water on its surface. As we know, liquid water is a crucial ingredient for life as we know it. Furthermore, telescopic observations and computer modeling have indicated the possibility of a dense atmosphere on TRAPPIST-1e, which could help retain heat and provide more favorable conditions for life. But wait, there's more. New analyses suggest that TRAPPIST-1e may have a protective magnetic field, similar to Earth's, which could shield its atmosphere from erosion caused by stellar radiation. So here we have a planet with liquid water, a potentially habitable atmosphere, and protection against radiation. Isn't that amazing? However, it's important to emphasize that we are still in the early stages of fully understanding these distant worlds. As we continue to investigate and refine our observation techniques, we can only dream of the exciting possibilities that TRAPPIST-1e and its companions could offer. Host stars, many stars have planets orbiting them, they are called host stars. Exoplanets orbit stars outside our solar system. If we observe an exoplanet from the correct angle, it will appear to eclipse its host star as it moves around it. By measuring the brightness of the star with the utmost precision, when the planet is passing in front of it, we observe a transit event described in detail in scientific articles on the subject, like the ones from Frontiers for Young Minds. To understand how researchers analyze these effects during transit, the planet blocks part of the star's light, and astronomers on Earth notice a decrease in the total amount of this light, which usually lasts a few hours. TRAPPIST-1 is a very small red star located 40 light-years from Earth in the Aquarius constellation. In fact, TRAPPIST-1 is as small as a star can be. If it were even slightly smaller, we wouldn't consider it a star because it wouldn't have enough size to produce its own light through hydrogen fusion in its center to helium. Its size is approximately the same as that of the planet Jupiter, although it weighs 80 times more than it does. Its brightness is only 0.05% of the brightness of the Sun. Many stars in our galaxy are as small as TRAPPIST-1, and due to their size and low light, they are not easy to study. This challenge did not prevent a team of astronomers based in Belgium from attempting to find planets around TRAPPIST-1, eventually discovering a true zoo of planets, 7 known exoplanets in its orbit, and all of them pass in front of it when viewed from Earth, causing transit events. We can calculate the size of each one by measuring the amount of light lost when it passes in front of the star. Small planets block little light, while large planets block more. Measurements of TRAPPIST-1's brightness revealed that its planets are similar to ours. The smallest is 3/4 the size of Earth, and the largest is 13% larger. The orbits of the planets of TRAPPIST-1 around its host star are much closer than those of our planets around the Sun. The closest planet, called TRAPPIST-1b, completes its orbit every 1.5 days. Compare this orbit with that of Earth, which takes a year to orbit the Sun. The farthest planet, TRAPPIST-1h, completes an orbit every 18 days. If all the planets of TRAPPIST-1 were placed in our solar system, their orbits would all fit within Mercury's orbit, the closest planet to the Sun. However, since the TRAPPIST-1 star has low luminosity, the planets need to be very close to it to stay warm. Stars are like fires, the closer planets are to the stars, the hotter they should be. However, the distance from a star is not the only factor that determines a planet's temperature. The planet's atmosphere must also be considered because some atmospheres keep their planets overheated and even roast them. Mercury and Venus provide good examples of the atmosphere's effect on temperature. Mercury is twice as close to the Sun as Venus, so naturally, one might think it's the hottest planet in the solar system. However, Mercury's surface temperature is only 842 degrees Fahrenheit, whereas Venus reaches a scorching 860 degrees Fahrenheit. The reason Venus is hotter than Mercury is its atmosphere, primarily composed of carbon dioxide, which traps heat, a phenomenon known as the greenhouse effect. Since Mercury lacks an atmosphere, it doesn't experience this greenhouse effect, so its temperature doesn't rise as much as Venus. The surface temperature of the planets in the TRAPPIST-1 system will depend on whether they have an atmosphere and its composition. Moreover, there's a wide variety of atmospheric types that could exist on each of these planets, capable of exerting a strong impact on their temperature. Who knows what the future holds in the exploration of these distant worlds? Stay tuned because there will surely be more exciting discoveries ahead. Many scientists believe these revelations will unfold gradually starting from this year. The James Webb Telescope not only expands our understanding of the cosmos but also inspires future generations of scientists, engineers, and dreamers. As this powerful telescope continues to generate and transmit data, us Earthlings eagerly await answers to some of humanity's biggest questions about the universe and our place in it. And the lingering question remains, are we also being observed? It's worth remembering that the journey of the James Webb Telescope is just beginning, and each new image is a gateway to the unknown. Until next time, universe explorers, a big hug and goodbye.